Bismillah ar-Rahman ar-Rahim, by the name of God, most merciful, most kind. Peace be upon you all, and God's blessing. We are going to talk about new content, which is how can we express permutation matrix as IJ expression. We have already discussed the permutation matrix for 3 by 3 as composed of 3 numbers. For instance, permutation P123 or 231 or 321, etc. in a previous video. But some of the reference books, for instance, Introduction to Linear Algebra book by Professor Gilbert Strang, using the IJ expression. So in this video, I will call it Num-06b. I'm going to refer to both IJ expression and how can we get the other expression or 3 expressions, as we will see. We'll move to the next slide. In some textbooks, for instance, Introduction to Linear Algebra by Professor Gilbert Strang, he uses IJ as an expression or 2 numbering for 3 by 3 matrix. I have noticed that I is bigger than J. I is the old position of the row and J is the new position of row. Let us examine 3 by 3 matrix. We have 3 by 2 by 1 options for expressing the 3 by 3 permutation matrix. First option is 1, 2, 3, P123, which is a normal position as identity matrix 3 by 3. The second case is the case when we consider the node 2. We have 2 options, either 2, 1, 3 or 2, 3, 1. The fourth option is when we use node 1, we can express by 1, 3, 2. We have last 2 options. We have permutation 3, 2, 1 or 3, 1, 2. Let us count all these expressions. We will find out that the total number of these permutation matrices equals 6. We have 1, 2, 3, 4, 5, 6. We have expressed that I is bigger than J. Most of these expressions for I is bigger than J. What about if I is smaller than J? If I is smaller than J, then we use multipliers of this IJ expression. For the third slide, this is the first case. Identity matrix, as we know, 1, 0, 0, 0, 1, 0, 0, 0, 1. In the left portion, this is first node, second node, third node. If we consider after swapping, we consider the expression of P21, IJ expression. I equal to 2, Jx equals to 1. So we have the condition of 2 bigger than 1. We have node 2. When we swap P21 to row 2 will come up, and accordingly the first row will go down, while the third row is remains. So finally, if we want to express P21 as 3 numbers, it will be 2, 1, 3. This is the case, the identity matrix prior to change, and as P21, it will be expressed as 0, 1, 0, 1, 0, 0, 0, 0, 1. If you look at column-wise, this matrix, if we consider it to be after on the right-hand side of any normal matrix A, when we multiply A by B21, we can consider it as C213, which means that after multiplication, the second column will become first, and the first column will become as a second column, new second column, and the third column will be in the last position. So we consider that for P21, we are writing swap R2 to R1 and keep R3 in the same position. This is R3. We will move to node number 3. But first, we are going to consider the identity matrix without any swapping. We have 1, 2, 3. The other expression is P31. P31 is swapping third row to the first row, and accordingly, the first row will come down. We notice that the second row, there is no change. So finally, the third row becomes up, and the second row remains the same. The third row will become down. So we can express that P31 is the same condition as P321. P321. At the same time, I is bigger than J because 3 is bigger than 1. We can write B31 as B321. So the B31 is 001, 010, and 100. This is the B321. If you look at column-wise, we find that the third column become as first column of the final matrix, followed by the second column, and the last third column is the original first column. We'll move to the next slide. For node number 1, we want to express the permutation matrix P32. Okay, this is the normal position or identity matrix 1, 2, 3. I want to make swap and from swap row 3 to row 2, and row 2 will come down. This we call it B32 as IJ expression. We'll find out that row 1 remains the same, and the second node will be 3. The last node will be 2 because we make swap from 3 to 2. So we could say that P32 can be expressed as P132. As IJ expression, when you are dealing with node 1 is here, I is bigger than J because I is 3 and J is 2. So P32 can be expressed as P132, which means that it is 100, 001, 010. If you look at as column-wise, we look from here, the first column remains, followed by the third column after multiplication, and the last column is the second column of the old matrix. Let us review what we have considered so far. We have the identity matrix. We know it is B123. It's the same identity matrix. B21 as IJ is equivalent to P213 at 3 number. B31 is B321. B32, this is our case, is equivalent to B132. As we know, we have 6 cases, so we have remaining 2 cases. Remaining B231. B231, it can be expressed as a multiplication of B132 by 213, or as IJ expression, this is B132 as we said, B132 is B32, and B213 is B21. So in order to get the expression of 231, we are going to make two operations. Let us find out what are these two operations. This is the identity matrix 1, 2, 3. If we want to get 2, 3, 1, we'll swap first row 3 to row 2. Row 2 will come down. So we get the new position as 1, 3, 2. But again, we need to make swap from the second to the first, and the first will become the third new position. So from here, we have 1, 3, 2, but we need 2, 3, 1. So it means that this node 2 will move up, and the this first row will come down. So P3, 1. So now we have multiplied two matrices. First matrix is P32 by P21 in order to get P231. This is P231 expressed as 0, 1, 0, 0, 0, 1, 1, 0, 0. If you look at it column-wise, we have the third column followed by the first column followed by the second column. We'll move to the last slide. We have remaining only the last one, which we can express as 3, 1, 2. This is 3, 1, 2. We want to get it from the identity matrix 1, 2, 3. We need two operations. First operation is to move the second row to the first row, and accordingly the first row will move down. Then we'll make swap from the third row coming up to replace the second row. Then the second row will go down. So we have at the end B3, 1, 2. This is a multiplication of B21 by B32. Because here there is no any row that remains in its position. We shifted 2 to 1 and 1 become 2. Then we have moved the third row in the place of the second, and the second moved down to 3. So this is 2 multipliers B21 by B32. For B312, we will express it as permutation matrix 001, then 100 second row, 010 at the third row. If you look at it as column wise, this is the second position followed by the third position for the column 010, 001, and the first column is in the last position as last column 100. We have come to the end of our video. Thanks a lot. God bless you all. See you next time. Goodbye. Take care.